You know, when you think about microbiology, your mind probably jumps straight to bacteria and viruses, right? But there's this other massive, often overlooked world, the kingdom of fungi. And mycology, the study of fungi, has always kind of been the underdog. But what if I told you this hidden kingdom is every bit as critical, complex, and sometimes way more terrifying? Let's get into it.
So here's the game plan. We're going to start with the absolute fundamentals that set fungi apart. Then, we'll look at their strange and diverse forms and explore their two faces, as both our greatest friends and our deadliest foes. After that, we'll get into how they actually invade our bodies, how our immune system fights back, and finally, we'll dive into the high-stakes arms race of antifungal medicine.
All right, first things first, what is it that makes fungi so different and, frankly, such a huge challenge for modern medicine? Well, it all starts at the cellular level.
Okay, this is absolutely the key thing you need to understand. With bacteria, things are, well, they're simpler. Bacteria are prokaryotes, their cells are basic, totally different from ours, which makes them a relatively easy target for drugs. But fungi? Fungi are eukaryotes, just like us. Their cells are complex, they have a nucleus, they are alarmingly similar to our own cells. And that creates a massive problem. How in the world do you design a drug that kills the fungus without poisoning the patient?
Okay, so let's get into the architecture of fungi. They're amazing builders. They don't just have one blueprint. They have this whole toolkit of different forms they can take, from tiny single cells to these vast, sprawling networks. So first up, you've got yeasts. Think of these as the single-celled minimalists of the fungal world. We're talking about things like Candida albicans or Cryptococcus. And they reproduce by budding, which is wild. A single mother cell can literally sprout multiple daughter cells at once, which allows their populations to just explode.
And then you have the molds, like Aspergillus or Penicillium. These are filamentous. They're built from these long, branching, hair-like threads called hyphae. You know that fuzzy patch on your old bread? That's a mycelial mass, basically a visible city built from millions of these interconnected hyphae.
Now, this is where it gets really clever and really dangerous. Some fungi are what we call dysmorphic, which means two forms. A pathogen like Histoplasma capsulatum might just be hanging out in the soil as a harmless little yeast. But the second it gets inside the warm, nutrient-rich human body, bam! It shapeshifts into its invasive, aggressive hyphal form, which lets it literally tunnel through our tissues.
Now we have to talk about their armor, the fungal cell wall. And this thing isn't just a barrier, it's a fortress. It's built from complex sugars called polysaccharides, like mannan and beta-glucan. It's reinforced with chitin, which is, get this, the exact same tough material that's in an insect's exoskeleton. And crucially, its membrane contains a unique sterol called ergosterol, which is different from the cholesterol in our cells. This entire structure, the mannan, the beta-glucan, the chitin, and that ergosterol, is ground zero in the battle between our bodies and these invaders.
But, you know, it's not all doom and gloom. Fungi aren't just villains. Their kingdom is vast and complex, containing some of our greatest allies and also some of nature's deadliest assassins.
On the friend side, we owe them a lot. Think about Saccharomyces cerevisiae, the yeast that gives us bread and beer, and Penicillium notatum, the mold that gave us the first antibiotic and changed medicine forever. Fungi are also used to clean up the environment through microremediation and form vital mycorrhizal relationships with plants, helping our forests grow. Pretty amazing, right?
But there is a dark side. Fungi produce mycotoxins. These are powerful chemical weapons, what biologists call secondary metabolites. They aren't essential for the fungus's basic survival, but they are used for warfare, and they can cause a severe disease called mycotoxicosis if we ingest them.
And this table really shows the sheer range of their power. You've got aurellanine from the fool's webcap mushroom, which causes irreversible kidney failure, and there's no antidote. Then there's aflatoxin B1, produced by Aspergillus flavus on grains, and it's one of the most potent natural carcinogens known. But then on the complete other end of the spectrum, you have psilocybin, a psychoactive compound being researched for its incredible potential to treat severe depression. Friend and foe, all in one kingdom.
Okay, let's get clinical. How do these organisms actually make us sick? We can classify fungal infections or mycosis based on how deep they manage to invade our bodies.
It starts at the surface with superficial infections caused by fungi called dermatophytes that literally feed on our skin, hair, and nails. Think athlete's foot. If they breach that barrier, it becomes a subcutaneous infection in the deeper tissue. But the real danger, the life-threatening stuff, is a systemic infection. That's where the fungus gets into the bloodstream and can spread to any organ in the body.
And here's a perfect example of a superficial infection that blows people's minds. Ringworm has absolutely nothing to do with worms. That red ring is actually the expanding visible front line of the mold's hyphae. It's the growing tip, releasing enzymes to digest the keratin in your skin for food.
Now for a major opportunist, Candida albicans. This yeast lives harmlessly in most of us, but in a host who's weakened, maybe by other illnesses or even just broad-spectrum antibiotics, it seizes its chance. Its key weapons? That dimorphic switch to invasive hyphae and its ability to form these resilient, slimy biofilms on medical devices like catheters, which can lead to deadly bloodstream infections called candidemia.
So if we're surrounded by fungi all the time, why aren't we constantly sick? Well, it's because our immune system is locked in a constant, sophisticated molecular war with them. Let's head to the front lines.
So how does our body spot them? Our immune cells are covered in scanners called pattern recognition receptors, or PRRs. They're programmed to detect specific barcodes on fungi called PAMPs. As you can see here, when a receptor called dectin-1 sees the fungal barcode beta-glucan, it triggers the immune cell to eat the invader. When other receptors, called toll-like receptors or TLRs, spot other barcodes like mannan or kitten, they sound a different kind of chemical alarm, kicking off inflammation.
Which leads to the obvious question, right? If our defenses are this specific, we have all these scanners, how do fungi ever win? Well, for every lock our immune system has, fungi have evolved a way to pick it. Fungi have this whole bag of counter-espionage tricks. They use stealth, rearranging their cell wall to hide the beta-glucan barcode from dectin-1. They deploy decoys, shedding proteins to jam up our immune receptors. Some even use armor, producing melanin to protect against our attacks. And the most devious tactic is sabotage. They release toxins like gliotoxin that disarm our immune cells from the inside, allowing the fungus to survive and even grow inside the very cells sent to destroy it. And this brings us to our last line of defense, medicine. So let's look at the drugs we've designed to fight fungi and the alarming new front that's opening up in this war, resistance. Our antifungal arsenal is pretty clever, targeting those unique features of the fungus. The azoles stop the fungus from making that special sterol, ergosterol, which destabilizes its whole membrane. The pollenes go a step further. They bind directly to the ergosterol and punch holes in the membrane, causing the cell to leak to death. And the echinocandins attack the cell wall itself, stopping the production of beta-glucan.
But here's the terrifying reality. For patients with a severe fungal lung infection called invasive pulmonary aspergillosis, the mortality rate is as high as 86%. And the fungus causing it, Aspergillus, is becoming more and more resistant to the very azole drugs we rely on to treat it.
And here's the final unsettling thought. Those same azole drugs we use in hospitals are used extensively as fungicides in agriculture. This is creating a massive training ground for resistance out in the environment. We've all heard of bacterial superbugs. The question we have to ask now is, are we accidentally creating the first generation of fungal superbugs? And is the hidden kingdom about to become a much more visible threat?